Hello and welcome to today's Saratech Enablement session. My name is Andrea Hall and I'm the Customer Relationship Manager here at Saratech, and I'll be your host today. Presenting today, we have Richard Benoualid, and he is a Senior Applications Engineer here at Saratech, and he's going to be talking to you about NX mechanical routing. Our sessions run about 30 to 45 minutes each, and they are all recorded and posted to our Saratech YouTube channel. Make sure that you check out our past sessions there. Twice a month, we meet right here to learn about tips, tricks, new and old features that'll help you in your everyday tasks. This is an open forum, so if you have questions or comments during the presentation, please type them into the questions box on the right-hand side, and I will kindly interrupt Richard and just let him know about your comments and questions right there on the spot. We also will have a short survey right after the session ends, and you are welcome to type in your questions, comments, and give us any feedback there, so please stick around to the very end. And with that, I am going to pass it over to Richard.
Hello, can you hear me fine, Andrea? You can hear me, everybody?
Yes, loud and clear.
Yeah, thank you. Thank you. Okay, I'm Richard Benoualid, and welcome. Thank you for joining us today. I work for Saratech. I'm a Senior Applications Engineer, and my background, I've worked in aerospace for 2 decades, notably Honeywell Aerospace. I've graduated mechanical engineering out of University of Montreal and Masters, and I live in Arizona presently. Today's agenda in this demonstration, this will be a live demonstration in NX. We will explore the different types of routing functions used to create a piping or tubing system. We will come out of this training or this demo with an understanding of the different types of routing capabilities, examples of path creation, the linear, the spline, the heel, the part placement from the library, creating a routing part from scratch, assign a stock, bend, and get stock length and bend reports, and manage the routing assembly and bill of materials. So I'm going to start there. So this is NX 1863. This is the continuous release of NX post NX 12. So this is one of the later ones. There's one patch that just came up. This is 1863. Now, let me open another file. We will start with, I was playing with that one. We'll open the boiler room assembly. And these files are mechanical routing files. And I'll show you how to create a new mechanical routing file after, which means that when you open the file, it recognizes that it's a routing object and it's a routing part. And so it has the routing toolbar already up. If it's not already up in the applications, we have the design application, manufacturing simulation. Out here, there's the routing application, electrical for cable, wire harnesses, mechanical, piping and tubing, HVAC. Logical is the 2D diagram. If you need add-ons, there are add-ons. We'll take a look at the piping and tubing add-on. But there is HVAC, platform, and mechanical. Electrical has the harness and cabling. Most of the routing, the basic routing, even electrical and mechanical, all have this similar toolbars with the 4 groups. The first group is creating paths, routing paths. There's segments. The segments make up a path. The stock, this is how we can add stock, edit stock, or create stock reservation. Placing parts from the library or moving them, and the utilities like the knowledge checker, interactive checker, and the routing bill of material. To get started, we will quickly create a linear path. I'll start at the left here. Right now we can't really see our ports, so one important functionality here is the preferences. Under preferences, there's routing, and we often go there. Since we're doing piping, this tells us which library to look into. The paths here, we're going to set some, look at this, the corners, it's fine at 350. The stock, these are the defaults. So we can set all our defaults right here. This is DN100, we'll come back to that. One thing that I like to get bigger is the routing display. Right now we don't see the ports very well, so I'm gonna make them very big for this demo. I could even make them bigger. And now we have big ports. You could see them out here. And I'll show you later on how to create a part with ports so we can put it into our routing. At this point, we'll go out and create a linear path. What I just did just now was set the preferences so that we have a 200 pipe. I set that already. I've set the default corner, and I've set the size of my ports. And that all depends on the size of, here we have a fairly large boiler assembly that's at least 10 meters long. So it depends on how big your assembly is. When you start routing, you can select points anywhere in space and just start routing. Right, the corners come in, the piping comes in, the stock. What I'm going to do though is I'm not going to do it in space. I will choose this port. Make sure to choose the port. It's very important for connectivity. And here we have different ways of specifying the points. I could go straight up to the window and specify the edge here, but that wouldn't be a very nice pipe. Stock offset points allows you to start the stock further than this point. You can define where to start it. Same thing with surface inside or outside. The stock does not need to start at the same point that the route starts. Dynamic and axis parallel we'll use the most. If you're doing more 2D, you can do it in X or Y. Dynamic axes here is the most popular and the most useful. This compass here is very useful. I could go straight out here and start moving the compass. I can move the compass out. We could then merge the stock. We can unify the stock. Let me go back. I can do Control Z to go back to the previous point. What I want to do is specify specific direction distances. I can select that arrow this way. It brought up the quick pick because I took an extra second on the pick there. Yeah, so I can move this out 2.4 meters. And then I can click on that little ball here also and rotate that 45 degrees. Could have put negative 45, it doesn't matter. I could put the negative here. I go for 4.2 meters. And then here I can rotate it again. I can select here. I could, of course, just take it and drag it as well. So that's the basic linear. What you saw in the linear here is I did everything in one kind of thing. I assigned the default corner and I specified the stock. Of course, it's possible to edit the stock or to create the stock after. If I had not created the stock automatically, I could have created the stock afterwards. I could have assigned corners afterwards. Right now, I want to show you one function that's in the piping. Once you have your first pipe path, I'll show you something that's very practical in the piping world. So I'm turning on the add-on piping here, and I go back to mechanical. What we could see is that now there's more functions in the piping and tubing area. It also brings up this bend report. This is probably one of the more important functions here, bend report in the piping and tubing. This sets up your machine for this pipe to be bent on a bending machine. I can apply here and I see the different bends through the different segments of the route. That's X, Y, Z. I could also bring up other characteristics. I could bring them all up. I can just shift and select them all. And now I have some other characteristics of this pipe. I can see that in a relative system moving along the length of the pipe. Here's a mill standard that many tools use. FIF is it's a file, it's a format interchange format. That's what it stands for actually. And it sets up the machine, actually sets up the machine for bending. So that's an important format for setting up the machine. And this machine here is for analyzing the pipe. It's a supravision, goes along the pipe. Again, another machine path that analyzes and makes sure the path follows the dimensions. So that's the bend radius tables. I'm going to back up a little bit and create a new file at this point. Of course, if there's any questions, feel free to ask. I'm going to create a brand new file, a routing file. When you create a mechanical routing file, you should select routing mechanical so that it sets up all the preferences and the default menus. That's a blank file. I'm going to take a look at the third part, the third grouping in the routing, which is place parts. So this goes to the library. And since I'm in piping and I define the piping library in my preferences, which I showed earlier, I can go in and start putting parts in my assembly. I could have created a platform, but I didn't. When you're in the library, there's many ways to check. I want 100 NPS. It's a nominal pipe size of 100 millimeters. I could type it here. Usually we would clear and do a search in the library. 100 NPS coming out both ways. So that's one way to go get it. I could have also asked for the table view or picture view. Table view is practical. A lot of information in the name. There's different ways to go get it. So the parts that you've used recently are listed down below. I'm going to select the 0, 0. You can select different ways of positioning. This is just like assembly positioning. I can select the existing point. In fact, I can use assembly constraints. If this was on a platform, I could right now use an assembly constraint to fix this part. That's the fix constraint. I can select
Richard, I
it.
do have one question from
Sure.
Jose. I'm not sure if this is a question or a statement, but it says mechanical routing needs special configuration if NX run integrated in Team Center. Do you need a little more
You would have,
clarification?
yeah, there's a lot of parts to that question. You do need
Okay.
a mock, you need Mach 2. NX Mach 2 has the routing capability. You get to Mach 3, you have more routing, but the add-ons, you would need to also get the add-ons so that you have the piping as well on the NX side. I can get more information on the Team Center side for you, but it is integrated with Team Center.
Mhm.
I think it's just a design object in Team Center that holds the routing parts.
Okay.
It's also integrated with Team Center classification as well. If that person can give you his name or her name, I can give more information on that integration with Team Center.
Yep. Okay. Jose, we'll go ahead and
Yeah,
email you afterwards. Perfect.
great. Thank you.
Sure.
Thank you for that question. So that was an assembly constraint I put on this. I just fixed it to the ground so it doesn't move. It could have been on a platform and I could have put a distance of 0 or right now I'm going to put another part inside here. Let's put one of those compensators on the other side. So again, I'm going to my library and I'm putting in devices right now. This time I'm just going to look at the table. I know that I'm a DN stands for diameter nominal. And that's how we're going to be doing 100 millimeter diameters. At this point, I can select the point feature to position. I could also just select an existing point or indicate in space and move it afterwards. This is just positioning this part in here. Oh, pardon me. I have one more OK there I forgot to press. And as you can see, it actually creates the assembly. This is like it starts adding the parts into the assembly. To do that again, I didn't press OK on that one. Okay. In order to see this a little bit better, I like to get rid of some of the things that we're seeing here. We could get rid of the datums. We could get rid of the sketches. Again, we see the ports. That's what's important. And here I'm going to show you again linear very quickly. We covered this very quickly before in the boiler room. But I could select this linear path. I could go dynamic axes over here. I could even eyeball that somewhere over here. And then I can go over here. This other function, axis parallel, is very practical when you need to go up to a certain point and stop. And then I can select the next vector, go to that point and stop. And at this point, I'm right in front of it. I can just specify the point. So I wanted to show you that also. One more, I'm going, when you're creating these things, right now I'm up here, I'll show you a little bit about assembly management soon, but right now it creates a stock. We could always delete routing objects this way, or I can select everything if I want to delete routing, all the routing objects. That's a special function in here called delete routing objects, which is practical. I want to show you another route. That's why I deleted it. So I can show you now the spline path. So spline path is a spline. I can select points in space. And then finally, I need to select that route path. Important to look at the minimum radius over here. That min radius is important for hydraulic tubing, for example. I can move these around. The spacing on the two ends, we can change those as well. I can go to 0.1 and put a forward extension. That's the extension at which it stays tangent on that end. I can keep holding that as well. I could do that on the other side as well, 0.4, and keep that tangent a little longer. Put an extension in there. So that's a spline. If I want to edit the spline, there's many ways to edit the spline. 1 minute, let me get rid of this. If there's a knowledge advisor in piping and tubing that keeps coming up, and we'll get back to that knowledge advisor, but I don't need it running right now. So I just turned off the piping. If I want to get the length of this pipe, I can go into menu, information, routing, and I can go get stock length. All right, I have my analysis window on my other panel here, the information window. Say that again. Here it is. Sorry about that, the window was hidden. Total stock length right here. I can get the total stock length, or in this case, there's only one stock. So that's how you would get the stock length. I got a little bit sidetracked there, but one thing I was going to do is edit the spline. So one thing you can do with any spline is edit the points. One thing I want to show you though is this slack mode. So what I could do in slack mode is I could do moving points. So I have a few points here. I can add additional length. I could add 500 millimeters. You could see that the points are moving because I asked for moving points. I could have asked for points in between. So we have a slack mode right now. We could, when you ask for additional length, if I were to move this part, the additional length doesn't take away from the ability to position that anywhere I want. And but if I were to do it with a fixed length, then it would stop me if I get spline path. Sometimes we do that to make these radiuses smaller, right? That's one of the reasons. Again, if I go moving points, what I could do is do a fixed length. Sometimes we have two, maybe we want 10 meters. We have 10 meters, but it is fixed length. So because it's fixed length, I can't move this anywhere I want. If I start moving it this way, it's fine. But as soon as I go over here, I gave it 10,000. So it's gonna, I need to pull it out quite a bit. And then it stops. Actually, it stopped right there. There's a 10,000 lengths there. This is 3D, so
Hi,
it
Richard.
stops
Someone
there.
said the video has
Yep.
frozen, but it just now popped up, so it might have been on his side, but I don't see it frozen. If anyone else sees that the video has frozen, please go ahead and send a comment in now. But if it did freeze, it's definitely moving for me right now. So sorry. Go ahead.
Yep. So I just wanted to show you those different spline modes, with the fixed length, additional length, the slack, the ability to move any of the points, add extensions. So spline is a fairly nice feature. Mostly used in tubing, a little less in piping. We'll get into a specific piping. I want to do one more thing while I'm here though, is I might want to put in my own parts. Maybe I have my own routing, so let me bring that up. So I've created my own part, very simple. All right, it's just a revolution of a sketch. It's as simple as it gets. What you need to do in order to make this a routing part is you go to the part dialog under more, still in mechanical routing function, qualify part. And over here, I want this to be a fitting. So I go right mouse button, new. I'm going to define this as a fitting so I could use it. And it could be any, it doesn't have to be a fitting. It could be, it could be your own, your own parts. It could be large parts, cases or boilers or anything that you guys make can be created with ports. You could give it a port name. You could have a flow direction, but I'm not going to do that right now. I'm going to go either. So we have a vector on one side. We want it to be either way. I need to create a fitting on the other side. Now I have that fitting there. Maybe that's out too. You have extensions. You could put the extension right here. You saw me earlier with splines putting in extension. This one will come with a default 200 extension. That's so that spline stays straight coming out for 200 millimeters. So now that I have this qualified part, I could at this point add it to the library. Okay, we don't have time to show all the library capabilities, but that's found in UG mech libraries under your Siemens directories. You can save it there. It'll go into your libraries. You'd have to update a library packs file. At this point, I can just save it to my hard drive as well. Give it a name. Qualified. I could go back to my assembly here and I can add this qualified part into my assembly again by placing the part. This is routing capability. It understands that it needs the ports, which I just created. I could open from the hard drive right here, or I could choose from a tree. I can do many different ways. I just created this qualified hose here, hose fitting. I am just going to give it a position in space. And at this point, if I want to route again, I can use my spline path, select the port, and this side and that side. The extension kicks in here. You have a minimum radius. And this one also can be moved around. It's all associative. And the magic compass allows you to move things around. There is a function that I'm also not going into here, which is called a deformable assembly. If you are using this, a deformable part, you could define this as a deformable part so that when you bring it into an assembly, you attach it just on the ports and it deforms. It's so this is more hydraulic tubing. I'm going to go back to the boiler room now. Any questions at this point, Andrea? Because I'm about halfway through and I think there's not much time left, so I'm going to be accelerating a little bit here.
It looks like, I'm not sure if you covered this already, but Dan wants to know, is there a way to see a hollow stock? His looks like a cylinder.
Yes, yes, good question. Actually, sometimes you want to see these hollow, so I have a view here. Yeah, right now it's just a cylinder, but all of these do have a definition. That's over here. It's in the settings, the style. If you go down to style here, you could just get a center line, but detailed solid allows this to be viewed as a hollow tube. It does take more space in large routes, virtual memory, GPU, if you have a really large assembly and you turn them all detailed. You could set this up in your preferences as well. Over in preference, routing, it's on the stock side. Oh, here, style. It's a small pull down here. So you could set that to details. So from here on in, we'll get all the details. That's a good question. Thank you for asking that. Okay, I'm going to move on to creating the next type of. So we saw the linear paths, we saw the spline paths. I'm going to explain the heel path, and the heel path is really the coolest one. The heel path can do what splines do and can do what linear paths do, but it also does collision detection and finds its own path through a boiler room like this. Let me just recenter this. I'm just going to set a rotation that's more appropriate here. Okay, so here all I have to do is select one path end over here, the port, and then I'm on 300. I'm going to change my stock. Stock also comes from the library, by the way. In this case, I need a 200 nominal pipe size stock. I could search for it, or I can look for it like this. B&W is a company in Texas that makes pipe stock. I think Siemens has their library, and there's a lot of libraries that can be pulled in. Over here, I will choose this port. And then down here, I need to choose this port here. Actually, before I do that, I missed a step because I wanted to touch. I'm going to back up here. I could select OK, but I'm not going to. I'm going to back up just one step here, and I want to show you something that's assembly management. I said I would touch on this. This is where assembly management, as I'm creating these routes, they're all going to be at the assembly level. What you may want to do, I'm going to do this quickly here, is create a new part that will contain all this routing. So routing mechanical, I can call this my routes, or probably a part number. Okay, now I have my routes down here. I can make this the work part so that all the routes go here. One thing we need to do though to work without having all of the error messages pop up, do you want to link and do you want this to be waved? I like to do my wave linking beforehand. You can select the wave geometry linker, and there is a routing object in wave geometry linker, so I can just go ahead and select the ports that I want to work with at this level. So I wanted to just do that because this is the proper way of doing it. You know, so you have the routes over here and you have your different components up here.
Hey,
So
Richard, we
here,
have another
once I'm in
question
the,
here.
sure, go
Okay,
ahead.
from Jose again. Supposing we are routing a flexible hose, is it possible to create a drawing with the tube straight?
Yes, yes. You would have to model it straight and create that tube straight. Um, you know, let me just bring up in the smart, go to the technical doc here for deformable part. The deformable part has two main panels. One is to create it, and once you create it, you can create it straight, and that would have a drawing. But then once you're in your assembly, you go to this deform component, and that allows you to change that tube into any other size. But you would have to model it straight, and have the drawing straight, and then be able to deform it here. I could do an example of that, but we don't have time. Again, this is one where if you want us to get back with you, I can show you how the deformable parts work. Thank you for the question, and I hope that makes some sense with deformable parts straight, and then you deform it in the assembly with that function. Over here, I'm going to show you the heel. Back to mechanical. So heel. As I said, heel is the coolest. You could just select the 200. Here we're on 200. Let me go back and get my 200 NPS pipes. And I know my default corner is 350. I'm going to do this with lines. So I've already selected the first one, and then this one, the end of the path goes here. What this does, it seems to have chosen the best one already. It looks for the best path around. It's looking at the extensions on both sides. It's looking at the walls. It sees up and down the assembly for collision, and it routes through the hole in the ceiling here. I have other choices. That one I know is the best because this one would go right through the part. This one works. If I go Z first, then I think it's going, that could work, but then it's going through the roof over here. So the best one was this one here. The heel is pretty cool. It does everything. Actually, that's not the one I wanted. Let me do that again. I chose the wrong one in the end. I don't want the one going right through the part. I wanted the one going right around the part. There we go. And then let's do the other one. That's the other thing that's pretty neat is it sees itself, so it doesn't collide with itself either. I can choose this one. This one is a 300 pipe stock. I'll keep the default corner at 350. Yeah, I didn't choose the right one again. So let me do that again one more time. Usually I get it right the second time. So that's not the right path. Let's see if there's another path. That's not going to be right either. just saw, I think it has to go Z first. And then underneath, can I get it to do this? And by the way, these paths are, if I wanted to, I can pull that a little bit that way. I can change it a little bit to my liking. I can move some of the extremities. And then finally, once I like it, I can do it the right way so it doesn't collide. And in here, I can go get information again, just like I did earlier, information about this pipe. I can do information about the route itself, about the parts themselves, or I can, over here, there's different options that you'll see often. You can do a path. This is the second time it does that. It loses my information window. One more time. Let me just do a measure. Come back in. Stock
Someone did have a
length.
comment here. It says it looks like the first pipe into the lower, looks like the first pipe into the lower box is not straight. It's at an angle.
That shouldn't be, because it's probably the angle of my window here, the way I'm showing it, because we chose X, Y, Z as the, those linear ways of pushing it. If that is the case, there is an align functionality. I just want to finish with just showing this, but I'll show you in a second the aligned function. If the pipes have, let me go back there. Misalignment, I was going to say you can align it. There's a, too many things at once. I'm going to move on to the next one here. It's kind of locked up. I'm not sure why it just locked up right here, but it's something with the information window that's not popping up correctly right now for me. I think it's because of the video is, and it might be going on my other screen, but I'm not getting that. It's like one, let me see if I can do it again. The analysis window is not coming. Information, routing, stock length. Let's see if I can get it again here. Stock, apply. Okay, I could get the stock length here. Stock, never mind, it's working. Details is, if I want all of the stock, yeah, this is where there's an error here. Better do one stock at a time. It doesn't like to choose both of these stocks at the same time. Maybe because one is 200 NPS, the other one is 300 NPS. You can measure one at a time. Now, pardon for that. You could also take a look at the routing objects as a whole. Any one of the objects can be viewed and information can be taken. I want to show you something that works a little bit better in terms of getting the information. I want to create one last thing. I think I have just a few minutes. I want to go back to this route mechanical model. I'm going to delete a few things here and create a real piping with the interactive knowledge check if I have time here to delete these. And I'm going to remove this one as well. So I have this assembly here. If I just go ahead and create this heel path right from here to here, and I position it, I could put offsets. It's a little bigger. Over here. This is the wrong pipe size. Let me just show you edit stock. I could easily edit this stock here. It's already chosen, and I need this to be 100 NPS stock. I didn't change it from the previous exercise. So I'll choose the 100. Okay, the pipe stock is the right size. However, if I go to piping and just leave it like that, like we've been doing up to now, and if I want this to be a real piping application, this is probably not good enough for piping as it is right now. And this is why we have this knowledge checker. We saw the bend report, but the knowledge checker here. Okay, there's a couple things that are wrong. This one's too short. So let's make that a bit longer. And specify it this way. My apologies. Okay, part. Oh, I know what I need to do. I can just edit the line segment here. Or probably this one actually. That's the route line segment. Excuse me. Right on line segment. And if I just do this, it will push everything out that way. But that would work as well. That would be one way of working it. But maybe you want the whole thing to be flat. What I could do is move this part. Even though I fixed it, it would let me move that part. Tell me, do you really want to move that part? Minus 2000. Make that longer this way. I think I can do the same thing on the other side. There's a knowledge advisor that says it needs to be at least 1 meter out. So let's just pull them out. Okay, then I go back to my knowledge advisor and it's going to tell me something else. This is incompatible connection types. So, that's why I went down this path, just to show you that these two, this is a butt weld coming into a flange. So essentially what we would need to do is, actually let me delete this routing object. What I'm going to do is place some flange parts. Actually some end forms that are flange parts, flange tubing here. If you're doing real tubing application with a knowledge, interactive knowledge, they will want to make sure that you have all your connection types correct, all your minimum lengths correct, all your radiuses have to be correct. So here, this is one correction. So now once I have that correction, I can come in and do a heel path. And there's still one of these that is too long, is too short here. It's this one up here. Seems to be too short. I'm sorry, wrong path. I have to edit my stock again. I forgot to reset it to 100. Let's do that one more time. It's good practice to set that in preferences before routing. I do my knowledge checker. No violations because my pipe was too big, so it needs a bigger length. It's a factor. So that's a knowledge checker. If you want to see all the knowledge rules that run in here, you could always go to the menu, information, routing design rules. This gives you all the different checks that take place. So this is something specific in piping. There's different design rules if you're in HVAC. Here also, one thing I didn't show is the routing bill of materials. So if I place it here, it's best seen in the, looking down the Z axis. Could put it a little closer, but there it is. Now I can go to my settings in the bill of materials. I could include everything. I can ask for itemized. I can ask for a list of each. If I go up here and update my parts list, we could see here's my weld pipe. That's the full length. I didn't give a name to the flange tube here, but there's two of them. There's a compensator on one side and there's a three-way globe valve on the other side. Nothing stops me, of course, from adding other parts in between. Or if I want this, for example, if I want to remove this corner and add a stock corner, I can go do that. That's an elbow. It's under fitting elbow. It's a 190 over there. Okay, let's reselect that to make sure to really get that control point, routing control point. If you don't get that routing control point, it throws that corner off and into space, you know. So you need to have it there to replace your routing. And then good piping, it's probably better to put in a real corner than to bend. It's, you know, up to, you could get a bend report for this side here, you know, in the bend report, and in the table of contents over here now there will be that extra corner should appear without even updating this. We have that elbow that we just added in is right here. If you need this part list to go on a drawing, you can export this in different formats, bring it in as a note table on your drawing. Andrea, I think I've even passed the 45-minute mark. I always go overboard. I start to get a little bit more comfortable after a little bit. With that, I'm going to have to turn it back over, but I want to say parting words here. I encourage you to try the routing tool in NX. If you have design needs, especially if you have design needs in like piping or tubing or HVAC or even electrical, cable, wire harnessing, I also encourage you to check out the classes offered by Saratech. And I really hope I get to see some of you in one of my classes in the near future. So Andrea, back to you.
Great
I'll put up the
job.
slides.
Thank you so much. Lots of great information, and funny enough, everyone has stayed on the entire time, so you must have been really captivating our audience today, so I appreciate you for that. And thank you everyone so much for attending. Like I said at the beginning of the session, we record all of our sessions, so we will be sending the recording to each and every one of you. Please feel free to pass that along to your friends and colleagues. Our next session, like I said, we're here twice a month. And our next session, which I just lost, is going to be August 15th, same time. And this time we're going to be talking about the feature-based programming in Milturn and NX CAM. If you've called our support line before, you may have spoken with Mark Anderson. He's wonderful. And even if you can't make it to our sessions, please go ahead and just register for them, and we will send that recording out to you. And next slide. As Richard said, we do offer lots of other things, services, training, and as well as 3D printing and hardware. So if there's anything that you need or you have any questions about what we offer, please let us know. And make sure you subscribe. Next slide, if you just subscribe to our YouTube channel, you will be informed of whenever we post videos. We post longer videos like today's, and then we also have lots of other short, helpful videos that our customers are loving. So make sure you check out our YouTube channel. And if you could just stick around for about a minute afterwards, 30 seconds, and just fill out the survey, let us know how we did today, that would be great. There's also a section in there that you can give us suggestions for future sessions. We do take those to heart. And again, Richard, great job today for your first customer enablement session here with Saratech. So we appreciate all the hard work you put into
Thank
this.
you.
And
Thank you
thank you
very
to
much.
all of our customers. Have a great day.
Bye.
Bye-bye.